Hello everyone, and today we're lucky to have David Sperґелом here, who's a really very interesting person, and I'll tell a little bit more about him. Today we have our usual Kуншткамера, but finally offline. Kуншткамера is a type of our interview when we invite people, and sometimes our audience can be here present, but we're recording this, we're taping this. And we're here now inside of Ukrainian Catholic University, where Lviv Data Science School is being held. And it's the project that is made together with Simon's Foundation and United States Academy of Science and actually Ukrainian Catholic University. And so, as I've said, we are really lucky to have you, David, here. Thank you for coming. My name is Oksana Brushnivska. I am a science journalist, and I'm also an editor at Kunsht. Kunsht is Ukrainian popular science media. And also, as I've already said, we have a couple of people who are our supporters. We call this our friends of Kunsht. And also, finally, as I already said, we have David Sperґелом here, who's the president of Simon's Foundation. Also, David, you are well known as being a participant of the project of Wilkinson microwave anisotropy probe. Later, I will use abbreviation WMAP, and many other works and papers, but also here today, as if I understand correctly, you are mostly because you're the president of Simon's Foundation, and there are many things that you're doing now here in Ukraine, and we would like to talk about all of them, and probably not all of them because I know it takes a lot of time, but also we are really interested in what you've been doing as a scientist, and also a very interesting topic that everybody now speaks about is UAP, NASA's team for discovering what's UAP. UAP, it's how we call UFO right now. And we would like to talk about this and about your activities here. So we don't have one topic that we would really like to dive in, because we have really many questions to you. And thank you again that you had this possibility to come here. We're really happy, and we're really, lucky to have you here, because as I've already said, as I've already asked you if you're tired, because I know that you've been busy these days and everybody wants you here in different places, want to ask you something, want to hear something from you. But also, it's not only in Ukraine, as far as I understand, also public all over the world probably needs to know what you think about situations that are happening now. It's been already second week, 2 weeks ago. We had this situation in Congress where former intelligence official and ex-pilots, if I'm not wrong, claimed that they have the data about US government hiding facts from public about extraterrestrial or just non-human biological forms of intelligence. So first of all, hi, and thank you for coming. And second of all, how does it feel to be you in these situations when these news are coming around and these events during all of these inquiries from media, from probably other scientists, from public at all? How does it feel to be you right now?
It's an interesting time to be in the I wear many different hats. And they're all interesting in different ways. Right. I'm here in Ukraine because I want to see what we can do to help Ukrainian science and Ukrainian scientists. As a foundation, my day job is to be president of a foundation whose role it is to support basic science. And we do this both in the United States and throughout the world. And as the situation developed in Ukraine, it was clear that, everyone suffers, but since our job is to work with science, we want to see ways in which we can best support science and scientists, both here and Ukrainian scientists who had to flee and or in Poland or Bulgaria or so we've been looking at that. I felt to do this, it was important to come to Ukraine.
Thank you very much for doing this.
You know, both to send a message to Ukrainian students and researchers that the international scientific community supports them and in the struggles, and to be there and to be a representative of it, and also to learn what we can do. One of the things that my coming to Ukraine has done is it has delayed the release of the NASA report, because I said I felt I could only do so many things at once, and that the release was delayed from last week to probably next week because of this. And we can talk more about the reports in Congress.
I would love to.
But, you know, let me actually start by talking about the scientific method.
Okay.
And how we approach things. What I think may turn out to be the most important scientific result of this year came from actually South Korea. And the South Koreans have claimed, South Korean researchers have claimed to build high temperature superconductors. What this means is you have material that can carry power over very long distances without resistance. If this is correct, this will change the world energy situation. It'll make it much easier to produce power in one place and send it somewhere else. You can have solar panels in the Sahara powering Europe, right? And this, as people know well, the world were less reliant on oil and gas. Not only would this take power away from some of the most autocratic regimes in the world, the worst, right? It would also help us enormously in addressing the crises of global warming, which I think of as the great ecological crisis of the planet for our century. So this is potentially very exciting, but we don't know if it's correct. And the way science works is you announce something, you show what the data is, and right now there are literally hundreds of laboratories throughout the world following the formula in that paper. And it's all open data. And one of the things I'm very proud of in our role as the Simons Foundation is we support this website called the Archive, where all scientific papers are published, right? Many in physics and math and other fields. And you can just read on the archive or just read, you know, how to reproduce a result like this. And people are doing this. Now, we talked about this claim in front of Congress, where this guy got up and said, we have secret alien spacecraft that we have been hiding for 50 years, and we have non-human biologics. And he knows where they are, but he won't tell anyone. And they ask me how to respond. And it's like, could it be possible that something's hidden that we don't know about? Absolutely, I can't disprove that there's something hidden. But what we would need to know to understand this is we would want to know, where is it hidden? Let's see samples. You would like to have, if there's some spacecraft there that someone doesn't understand, you would like to treat it the way we treat the rocks that the astronaut took back from the moon. And that material is shared with labs everywhere. This guy who knows nothing about biology, as far as I can understand, says there's non-human biologics. By the way, a weird phrase in English. It's a phrase it's an English phrase I've never heard before in my life. And he then says they're there. And okay, if it's there, I mean, this is something that would be incredibly important if true, but we have to see if it's true. And he's claiming the military's hiding things. Our military keeps secrets, all militaries keep secrets. But they tend to keep secrets primarily from their enemies. And they honestly don't even do that so well over time. Secrets leak. And there's a class of secrets that militaries never keep. And those are secrets that will lead to increases in their budget. And the idea that over 50 years, the military had this great secret that would let them increase spending on understanding some alien threat. And they didn't let anyone know about it and didn't do anything to increase the funding is one of the reasons I don't believe it. To give you a little bit of history of the US military, like militaries everywhere, after the Cold War ended in the late 80s and early 90s, many of us hoped we were living in a different world. And the US and Europe decreased spending on military weapons. And a world in which we spend less on military is in principle a good thing. But if you're a military contractor, this is a bad thing. And if we had secret alien spaceships in the 1990s, it would have leaked so they could have gotten a budget increase. Now, this isn't a scientific proof. This is just my experience over many years working with bureaucracies. And I'm not expert on Ukrainian bureaucracies, but I am willing to bet that different ministries want to work to increase their budgets.
Yeah, that's, I think, good guess. I mean, the whole situation is very interesting, but it's not only about recent weeks. It's not only about the thing with what was said in the Congress. It has been like this pressure, this public pressure, this probably media pressure. It has always been since this topic is popular again. It's like we're again in 90s when X-Files is like on our TVs, but instead of X-Files, we have YouTube with lots of videos of like aliens coming and...
Keep going, but I'm going to pull out for you a picture of me with the star of X-Files. So I went to college with David Duchovny, who is the star of X-Files.
Yeah.
And David and I were at a bar together a couple weeks ago in New York City. David has a new film out, and he and I had drinks and talked about all the people who message us about their alien experiences. So
I had sleep paralysis when I was a kid, so I had some kind of experience.
So there you go.
Of being
there is me and David Duchovny.
Oh yeah. So this topic is really an interesting one to people because I don't know, we'll probably speak about the reasons people want to see some other type of intelligence somewhere out the world, out the earth, I mean. But this, lots of speculations, lots of questions to you, is something that has always been done, especially when this UAP team has started their work. So I remember an article on space.com and David Evans,
Dan Evans.
Yeah, Dan Evans, your NASA colleague, he said that UAP team is under the pressure, under the harassment because of their involvement. Why do you think this is happening? Why do you have to work under pressure? And which forms of harassment is this? What people want from you?
So sadly, most of the harassment has been online harassment of the female members of our team. And one of the very important, unfortunate things about social media and Twitter is, for some reason, I don't know, there's a lot of anti-woman hostility. This is not peculiar to us, to our team. This is happening all over the place. And I think this tells us this more about one of the most negative aspects of social media, which somehow online, people behave much more poorly, much worse than they do in person.
Of course, nobody sees them.
No one sees them. The anonymity enables very poor behavior. And sadly, that was very unpleasant for several members of our committee. And, you know, I think that many people have very strong views on UAPs. There are people who think that it is absurd to discuss it. And there are people who deeply believe that there are things hidden and that anyone who is not announcing that they must all be aliens landing every day is somehow hiding things. So it just brings out a lot of strong beliefs and a lot of hostilities. And the approach that we have tried to take to this is an approach of being scientists. And to start by saying, we want high quality data. Now we have examined some of the data that people have presented, and I think a lot of the events, probably most of the events, fall into several categories. There are some that are balloons, drones, and airplanes. Anything with flashing lights is human. You only put flashing lights on things when they want to be seen. I am not an expert on the drones used in warfare here. I promise you they do not have flashing lights on them. You send them in so they are not seen, not for them to, right? We put flashing lights on commercial planes and bridges so they're seen. There are two possibilities with aliens. They want to be seen if they're there, or they don't want to be seen. If they want to be seen, they're landing in Washington, D.C., and London, and Paris, and Beijing. If they don't want to be seen, they don't have flashing lights. Anything with flashing lights, we can ignore. So we can set aside those things. There are a class of things that are what we in astronomy call optical ghosting and things of that sort, a phenomenon that I think a lot of people are used to with their cell phones. If you take a cell phone picture of your friend, and instead of having your friend stand with the sun behind you, the sun is over there, you will often have your pictures come out very strangely, right? And what's happening is light from the sun is reflecting inside your camera. And there are some of the famous images that people talk about, like these rapidly rotating triangles. And those can be reproduced by taking the camera of an F-16 and pointing it with the sun over there. And it reflects in it. And the cameras on these planes are designed to track targets. So they wrap up with cable, and then if they get fully wrapped, they unwrap quickly, and that produces the triangle rotation. So, okay, so there's a bunch of events that you can kind of go through and explain what they are. One of the complications here is that many of the events are seen by military pilots. And for the United States, and I think for most places, any data taken by a military camera, any data taken by our intelligence satellites are classified. Not because of what's in the image, but because how the image is taken. Because if you see an image that an F-16 has taken of a balloon or a building, you can infer what are the optical properties of the camera. One of the things that got the US intelligence community very upset with Donald Trump about was several years ago when he was president, he made public images of an Iranian missile site. And he just released them on. Okay. And by releasing those images and seeing the shadows and seeing the you can infer the resolution and properties of the US spy satellites, right? And that's the kind of thing that has ramifications here today, is that our capabilities are known because of revealing pictures like that. So this is why lots of things with UAP events are sometimes classified, and people who don't understand this think there's a vast conspiracy. Well, there's a vast conspiracy to protect our spying and military capabilities. That's what's going on there. So that's one of the problems. Now, there are events, when you eliminate all these things, that we don't understand. And that's intriguing. Anytime there are things we don't understand, there might be something very interesting. And that very interesting thing could be some interesting physical phenomenon that we don't know. One of my favorites on this list is something called sprites. Sprites. I recommend S-P-R-I-T-E-S. I recommend that your viewers Google lightning sprites and see what comes up in images Google. And it's effectively these upward going lightning flashes, which are incredible patterns. And they were seen by pilots for many, many years. And they were just seen by eye. And people didn't believe they were there. And lightning sprites were not believed. And pilots were not believed. So it took the development of special cameras with very fast speeds to be able to see them and understand them. So that's one of the reasons I think it's important to study UAPs. Because it could turn out, well, they have nothing to do with extraterrestrials, but that there are things out there that we don't understand that are pointing us to something new. And one of the messages I think we want to get across in our panel is we want people to report anomalies. We want pilots to report anomalies. We want commercial pilots to report anomalies. Right now, there's a lot of stigma associated with a commercial or military pilot reporting something that they don't understand. And that's unfortunate because we're missing things. We may be missing new physics. We may be missing, almost certainly missing, information, this is from the US point of view, of people spying on us. Mm-hmm. So one of the incidents that happened in the US a few months ago was there was a Chinese spy balloon that passed over the US. And what has been revealed in the press is that there had been a long-standing program of Chinese balloons spying on US naval activities. And kind of the geopolitical context is, China would like to absorb Taiwan. Taiwan is an independent democratic state with its own identity. Its large neighbor thinks it's part of it and denies its identity. A story that may be familiar.
Yeah.
And unfortunately, Taiwan has the advantage of about 150 kilometers of water between it and China. But that means that China cares a lot about US Navy capabilities. So there's balloons, and we would want to have our commercial pilots report things they see. Those balloon events were probably seen and not reported because of the stigma associated with, you're talking about UFOs, you're a crazy pilot. So we want things reported. And one of the things our panel has talked about, and our recommendations are not for 2 weeks, but this is things we discussed in our open hearings, is the idea that we would like to get citizens involved. And we would like to get high quality data on strange events. And if there are extraterrestrials, and we have no convincing evidence there are, but people believe, and we should check hypotheses, we need to get better data. We would like to have very high quality images taken from multiple directions, and like to have GPS positions and everything else. Fortunately, we have about 3 billion of these on the planet, and everyone is walking around equipped with them. And
everyone's ready to record
so
things.
What I think we will want is an app that is optimized for recording events, records not just image, but your phone records the strength of a local gravitational field, the local magnetic field. It certainly records sound. It can compress images. It contains a lot of what we call metadata, when and where the picture was taken. You can be geolocated off of it. And if you have, let's say, 10 people see the same strange object, and they see it from different directions in time, you can infer what the distance actually is, what the velocity is, what the acceleration is. And what I hope we end up with is a public site where anyone who sees something strange can record the image. We can make the data publicly available, and people can sort through it. And if someone finds an interesting thing seen from 10 directions, they can reconstruct what's going on. So what I hope will come out of this is an opportunity for citizen science. And it may well show that all events could be understood, and they fall into certain classes and so on. If you have multiple images, it's never anything unusual.
Seems like this citizen science project can also help your team to reveal fakes, because it will be harder to make.
That's if you have multiple images and they're encoded, you can make it much harder to have fakes. And of course, there can always be manipulation of data, but that can also often be found. So I think, and I think a program like this, while it will mostly reveal lots of images of drones, you know, there's a lot of interesting drone technology that people don't realize is there, and it's being tested and flown. And I think more of the images will be drones or planes, whatever, but it could reveal something new, you know, and that would be very exciting.
Thanks. You also said that there are people who think that UAP project is not even worth discussing, and there are other people who think that US government hides facts. So I was trying to think how this confusion, where this confusion comes from, and as a science journalist, I'm not like running for hype. I'm trying to find facts and try to explain them with help of experts in a like more normal way. I'm just thinking of where this confusion where are the roots of this confusion. And I also think that maybe people just don't understand if we are not talking about, they're being told not to think that the US government is hiding something, some extraterrestrial forms of life. On the one hand, not to like stick to conspiracy theories and all this stuff, but on the other hand, they don't probably, I'm speculating right now, I don't know the real situation, but I just try to model this. They don't see in this UAP team, if I'm not wrong, like military who can reveal some military objects, or like meteorologists, or probably you have one, I'm sorry if I'm wrong, but they see lots of, like they see astrophysicist, astrobiologist, astronomer, astronaut. We also interviewed Scott Kelly. Scott, if you look at us. So there are lots of questions that probably they might ask you. Why are there so many astro specialists? And why are they exploring?
We have a number of people on the committee who have astronomy backgrounds, because many of us are used to looking at lots of data in extreme environments. We also have people with backgrounds in ionospheric physics, in oceanography, in policy and science journalism. We have a number of people who have backgrounds in working with satellite imagery and developing satellite imagery. For example, we have the Chief Technology Officer of Maxar. Maxar is the company that does images. Let me put it this way. Most Maxar satellites are deployed over Ukraine right now whenever possible.
Why I was asking this question, because I just think what is the main message we should tell to people so they could more like clearly understand what's happening
I think, well, first let me say about what our role is. Our role was not to advise the military. The military has their own system, program of doing this. The task we were asked to do is give NASA advice on how it could help advance understanding. That's what I see actually our job as scientists in general. Our job as journalists, right? How do we get people to understand the world better, both as a community of scientists, how do we understand the world better, and how do we convey our understanding to individuals, right? That's what we're aiming for. And NASA has a role in doing that. And NASA has a lot of resources, right? And some of those resources are its own satellites, which after discussion we realized are not optimized for looking at small things, right? They're really looking at weather, looking at larger scale patterns. So I don't see a large contribution by NASA's satellite imaging. Commercial and military imaging, downward-looking imaging is much higher quality for finding small things. What NASA has is the ability to collect and analyze and make public data. So I think NASA's serving as a source, a place where people could work to understand UAPs and do this in a very open way. One summary on Twitter of what our committee has said in the hearing I liked. I don't know what one's allowed to say on Ukrainian programs, but I'll summarize it and you can edit it. Those fucking scientists, they don't believe, they only want more data.
You can swear here, it's okay.
Okay. And I think that's a really good summary of what science is about. We don't believe. Just because you tell me you've seen something weird, that's interesting, I'd like to know more, but I don't believe just because you've said something, it's true. I want data. I want data that's well calibrated. I want data that's repeatable, that is verified, that I can, many other people have taken similar data. Let's go back to those superconductors. It's exciting that one group in South Korea claims to see something, when 50 groups around the world reproduces the result. And the nature of science is such that they will not only reproduce it, they'll come out with some variant on that material that's even better. And perhaps we will all have superconductors everywhere in our lives in a few years. It is done in a public and verifiable and highly calibrated way. One of the problems with a lot of the images we've seen is they are taken with cameras that are not designed to do high quality imagery. I mean, it's very disappointing that so many of the claimed images are so fuzzy. A little, you know, many people have emailed me strange fuzzy images. Now, I am not a great photographer. However, usually if I don't put my thumb in front of my camera, I can take a pretty crisp image. And when you blow it up on your computer and zoom in, it's pretty high quality. And that's not my ability, that's just the nature of modern detectors and modern cameras. So we'd like to see better quality things. Speaking
about those data, this night I had 13 30 minutes where I actually almost became a conspiracy theorist. Of course, when I stopped watching YouTube, I came back to a normal state. But there's a lot of UFO compilations everywhere. And we were talking about X-Files. X-Files were positioned as a fiction. It was obviously that people are playing a game. But when you open YouTube, it's really hard to distinguish what's true and what's just like false. And I prepared a little game for you. I know that you are tired of those videos.
So with X-Files, you know, I talked with David about this. Mm-hmm. And to me, it's amazing that people do not understand what an actor is. An actor is not the person, the character, yeah. Right? There are many different shows you can watch on TV. The only time I have seen a show in which the actor became the real person is when I watched the first and only time I watched a TV show in Ukraine. It was about this guy who was a high school teacher, and he went viral and became president of the country.
Oh, okay.
And then it turned out, like 2 years later, it turned out to be real. Yeah. So besides that show, I have never seen an actor who actually ended up being the person in the show. So people here may have a different experience.
We're unique, okay?
You're unique here. But David Duchovny is not an investigator of unidentified aerial phenomena. David is a very talented actor who's been in many different TV shows. I just saw a movie he produced for the big Tribeca New York Movie Film Festival. That's why I met with him when he was doing his showing. And it was a wonderful movie about a father-son relationship in American baseball. In the movie, he played the father. That was not his kid either. He's an actor. I mean, so this is like when you get to conspiracy theories, we have people who cannot distinguish between reality and make-believe at the level of thinking that actors are real. And David says 20 years later, people still write to him and think he's investigating aliens.
Yeah, of course. And it's more, I think it's way harder now on YouTube because there's nobody who tells you it's the story. You just go there and you see some data. And I prepared a couple really, really short videos. And I'm really, really curious. Could you probably give us some at least hint? I know that you can probably not be able to answer.
It's almost impossible to look at a video and tell you whether or not it's fake or not. I mean, I can't do it. You have to look at all the data around the video, and I can't do it watching it on your screen, so I don't think I can actually, you know.
But it's just interesting to know what you think when you see them. Like some of them, I watched all the 30 minutes of it, and some of them were so obvious it's fake that, you know, I'm not an expert, but I could clearly see it was fake.
I am not an expert on identifying image fakes. So this is not something I have a particular insight in.
But it's just still interesting on how can we at least, which direction of analyzing those images we can use. So like, for example, what can this be?
A flashing light?
Yeah, this green flash. Well, you see this? Yeah.
Oh, a green flash?
Yeah, green flash.
That's almost certainly an optical defect in the camera.
Okay. So the person didn't see this with his eyes?
That's right. It's
just camera.
Exactly. It's an optical defect in the camera. We see flashes like this in data.
I posted this when
it's like a rocket.
Was it?
Or it's either a rocket fume or a cloud. Oh, it's a cloud.
No, it's moon. This is moon.
Oh, it's the moon. That's pretty cool.
And,
cool.
And this is like, whether it's fake or... Do you see these little guys walking about the moon really, really fast? Mm-hmm. What are they?
They're almost certainly stuff in the Earth's atmosphere.
Oh, do you see them now?
I see the things moving around.
They have the shadow.
I see. They're almost certainly in the Earth's atmosphere. And I mean, those could be actually faked effect, but you know, let me put it this way. Astronomers look at the moon all the time. We have things orbiting the moon. These things are not being seen in much higher quality data that astronomers take.
What about this one? Can these be like these lighting sprites, or is this fake, or is this what?
Well, it's hard to know. So one of the questions you look at something like that is, I don't even know scale. How far away are they? I mean, this is one of the challenges in images, right? If I had many images from different angles of this could be anything from, there are events which are literally turn out to be insects crawling around on the camera of an airplane, right? So they could be right in front. They could be, and if things are right in front of a camera, they're out of focus and look fuzzy. So that could be nothing more than water droplets on the surface of a camera lens moving around in the wind. That would produce that effect. I have no idea if that's that, but you can, you know, have very simple things like that that are right in front. And this is why I think images from a single camera, from a single perspective, are very hard to know whether it's something that's against the camera or 1,000 miles away. I can't tell that. That's actually, as an astronomer, one of the great challenges historically, is it's very easy to get the position of something on the sky. It's very hard to know its distance unless you know its size, right? Something we're used to doing. So I see as a driver, I see a car in the distance. I know how tall cars are. The car is not thousands of miles away and, you know, are thousands of kilometers away and a kilometer tall. Cars don't come that way. Nor are they a millimeter high and right in front of me. I know a car is a few meters, and I from that can infer the distance. And if I see something odd, I don't know the distance. Now, if you take an image of it, and I take an image of it, and we realize that I see it from this side and you see it from that side, then we know that's a water bottle, and we know how big the water bottle is. If we're looking, you know, that's why it's so important to have multiple images from multiple angles in order to identify the nature of events.
There's some objects like ISS, you can only have, like, use one camera. Has it ever happened that some ISS team told you that they saw something, or like people caught videos from ISS camera with actual link to ISS to NASA? Because it was also, it's the last one, I promise you. This is the last one. It says this is from ISS live stream NASA camera. And there's something also, I don't know, it looks like fake, but has it ever happened that there was a possibility to check whether they really saw it and recorded it, or was it like, again, some effect because of something that dropped on camera, or how?
You know, I don't know what's in those images. They do look like they're lit objects. Again, things are only lit up if they want to be seen. So you don't, those are, if they're objects that are trying to hide, they are not lit. So when I see things that are bright and shiny and lit, I assume they are human. If they are distant things, they are human objects that are trying to be seen by others and not collide with each other.
The problem is these kind of information is being spread really widely, and people who wants to see that, who, you know, want to believe, they see this and they have like proofs. And again, information is being spread widely in uncontrollable, which is like, okay, people should post whatever they have to post, I guess. But then what happens? Media catch those data, and then they look more like serious because some media company wrote about it and used those files. And then even like algorithms think that this is reliable data. Have you seen now, have you Googled, or probably you know this case, for like last 3 weeks, the age of the universe?
Yes.
Do you know this
Yes.
situation? What do you feel about this?
Well, I think, all right, since my summary of what is the most important thing I've done in my scientific career is help make what is some of the most accurate measurements of the age of the universe. And we make these accurate estimates really from geometry. Because we know, we know that it's about 13.8 billion years. So it's annoying that when one group of scientists get what is, we will have to check it, but there's almost certainly some errors in their analysis, because everyone else making this measurement in many different ways all gets about the same answer, gets an answer that's a factor 2 larger. If you get an answer that's a factor 2 larger than anyone for a measurement, the first question, it's important sometimes you could turn out that everyone else is wrong and you're right. That's very exciting.
That might be.
Most of the time, you've made a mistake.
Yes.
And you should check, and in particular, you should check what are the assumptions that go into your analysis. And they were making those observations based on very incomplete approximate data where they fit a very uncertain analysis. So it's, it is very likely to be an correct result with some incorrect pieces. And unfortunately, there was a press release by some people involved that grabbed people's attention, and then it kind of propagated through search engines. And this is something where science journalists have a very important role to play. And this is something where I think the media has an important role to play. I'm a big believer in high quality journalism, particularly in the time of the availability of things in the internet. I like to, if I read an article about something that seems controversial, I like to see it covered in the New York Times, in Le Monde, in Der Spiegel, leading papers throughout the world, where Washington Post in the United States, Wall Street Journal, ones with different political perspectives, but all covering things with an intent to be factual. And unfortunately, there's some irresponsible journalists who are aiming to maximize the number of clicks on their website.
Course, these are views, these are money for media.
Yeah. So,
it's clickable.
It's clickable, yeah. So, the clickable metric is driving, I think, actually the spreading of misinformation, because I think for both journalists and scientists, our first responsibility is to try our best to get at the truth. Not to do the thing that gets the most attention, but the thing that best reflects our understanding of reality. And our understandings will always be incomplete. We will make mistakes, but we should always be striving for an understanding of reality.
Actually, why I asked you this question about the age of the universe, because I know that you were in a team at WMAP, where you actually discovered and proved that the age of the universe is more like close to 13.8 instead of 13.7, as we thought before, if I'm correct.
Well, at the time, actually, when we made that measurement, it was fairly uncertain. There were values from as low as 10 to 15 billion. There was a lot of uncertainty in the measurements. I would summarize what we did with our experiment, which we launched back in 2001 on we call it WMAP, and after our colleague
WMAP?
David,
Okay.
Easier to pronounce.
Yeah, it's clear.
And we measured the leftover heat from the Big Bang. We took what I think of as the universe's baby picture, in that it reflects properties of the universe when it was only about 380,000 years old. Back then it was simple, so we can use those observations to infer things like the age and density of the universe and its basic fluctuations. One of the things I've been doing here in Lviv is giving lectures, and lecture 2 was about that data, how we took it, how we do the analysis, and we talked about how we use those analysis techniques. And my goal was both to tell the story of those results, and most importantly, to teach the students and some of the young researchers here some of the techniques we used with the hope that they can be used on their problems. And it's, I think, an interesting story there about how we continue to take better and better measurements. When we made our measurements, we were improving on measurements taken by the COBE satellite launched by NASA, which led to their getting the Nobel Prize. And we confirmed their measurements and made more accurate ones. Roughly a decade after our measurements were taken and made public, the Planck team, a team led by the European Space Agency, with involvement from many in the US through NASA, took more accurate images, and they basically confirmed our measurements of the age and the properties, but then made them more accurate and measured some new things. Right now, we have an experiment operating in Chile. Our colleagues at the University of Chicago and elsewhere have experiments operating in the South Pole. And we're now looking at the same sky at even higher resolution and higher sensitivity. You know, you're looking at improvements of factor few in sensitivity with every decade as the instruments advance. And we keep seeing, and this is a great success for the experimentalists, the same basic picture, but it comes into better and better focus. And this gets back to our theme we talked about UAPs. What is very important is to have data that is reproducible, seen by many different people in different ways. So the detectors that we put up in our experiment, WMAP, are very different from the detectors in Planck, yet they see the same thing. The way you make measurements in space is completely different from the way you make measurements in a mountaintop in Chile, yet you see the same sky. And that's why we believe things as scientists, is we can reproduce them. And, you know, people have asked me, why did I get on the UAP committee? Well, fundamentally 2 reasons. One, because I have worked with NASA throughout my career, and when for me it was almost a matter of government service. When the government asks you to do something that you can be useful, you do it. The other is, I think it is an opportunity, is a teachable moment. And I hope one of the outcomes of this is we will not convince conspiracy theorists, but there are many open-minded people who just want to understand. And one of the unfortunate things about the nature of science is it can be difficult. And without years of training, it's hard to contribute. And I actually think one of the nice things about the study of UAPs is this is an area where if you see something strange and you can take pictures with your camera and share that data with others and be a part of a community that's trying to discover things, this is a great opportunity.
Speaking about WMAP, again, this project is like super cool. And it's like, I don't know, for me, it's like you were detectives investigating what happened in the distant universe long time ago, using like old traces that are just everywhere. And you made a picture of how it all looked, what happened, and when it happened. And I'm not, of course, the only one who's fascinated with this project. And even Stephen Hawking said to your scientists that your how you prove the inflation of the universe is like the most stunning. I'm not like quoting, I don't remember his exact words, but it was like the most stunning physics move in his career. What was the most significant, the most important discovery of WMAP for you personally?
How simple the universe turned out to be. So to explain what we do, more broadly as astronomers, it's because light travels at a finite speed. You see me not as I am, but as I was a few billionths of a second ago. We see the sun as it was 8 minutes ago. We see a nearby star as it was 10 years ago. It's 10 light years away. That's what it means to be 10 light years away. The further out you look in space, the further back you look in time. It takes light millions of years to travel from even the nearest galaxies to us. So we see them as they were 1 million years ago. We see a distant galaxy with the Hubble telescope, or even further with the James Webb telescope, that might be, say, 12 billion years old. When we look out at the microwave background, we're looking out about 13.8 billion years. We're looking out and seeing the universe as it was, in a sense, in its infancy, a few 100,000 years after the Big Bang. When we see it, we see a universe that's remarkably simple. What do I mean by that? I can describe the statistical properties of the millions of points on the sky that we have looked at with these experiments with basically 5 numbers. The age of the universe, the density of atoms, the density of matter, how lumpy the universe is, and how it varies with scale. So 5 numbers describe the property of 1 million fluctuations. Not only that, I can take those properties and predict, just using general relativity, how things evolve forward in time to make the galaxies we see today. So we can describe the large-scale structure of the whole visible universe, and infer that all those pieces from there.
The last question before the last question will be like, we've been talking about some speculations on the UFO or UAPs, but there are also some speculations. You say universe is simple, but not everybody agrees. I mean also like some professors of physics or whatever, not everybody agrees on everything. And there were also lots of speculation even about the cosmic microwave background. And my favorite one is about the cold spot, which is for some people is not like understandable from the point of view of like regular science. So they say that it should be an imprint of another universe, some parallel universe that happened like when the inflation started. And what do you think about those theories? How do you feel when you hear that?
I think they're exciting ideas and ones worth testing. So when, you can look at the predicted distribution of hot and cold spots. And if you look at the map and say, one of the predictions of the model, of its simplicity, is the hot spots and the cold spots have the same statistical properties. That I switch hot plus sign to minus sign and everything looks the same. That works on most scales most of the time. But there's one scale on which the cold spots are a little bit more extreme. And the question is, when you look at that, is that a statistical fluctuation? You roll the dice 10 times and you expect to get roughly equal numbers if they're good dice of 1, 2, 3, 4, 5, 6. But I roll it 10 times and I get 4 times. That's not so likely. There's 6 numbers. Is that a statistical fluctuation? One can work out the numbers. I don't do this in my head very quickly, but maybe that happens 1 time in 50. Now, unusual things are 1 time in 50 happen, but they shouldn't happen that often. And you and I have this discussion, and you say, those are not fair die. They keep showing 4s. And I just say it's a statistical fluke. It's easy to test. We roll the die more times. if the next time 4 comes up 6 times, I get pretty worried that those dies are what we would call weighted die. Someone put a weight on the bottom on the 3, so every time you roll it, 4 comes up, and they're trying to cheat at dice. But 4 comes up only once the next time. It was a statistical fluke. So what we do with the cold spot, so I think it's a very interesting idea. I think we should be constantly testing new ideas, that we could potentially see the collisions between possibly proto-universes in the Big Bang. And one of my former students actually was one of the people doing these analyses and looking at the predictions, and what she found when she looked at the Planck data, which, remember, the Planck data is 10 years later, improved data, high resolution, is that unfortunately, it was statistically consistent with simplicity. You know, we all want to find novel things. So I have actually spent a lot of time, and a lot of my students have looked for novel things in the maps. And others have looked, and they've seen hints of things. But every time we look more carefully, it keeps coming up simple. And, you know, the notion that the universe is so simple that we can understand it, and so simple that with pretty basic mathematics, you know, a distribution which was a bell curve distribution that we called a Gaussian, that some of you who have learned about in your mathematics classes, and describes many things in our universe, the distribution of people's heights, and lots of things are all fit by a Gaussian, fits the universe. And the whole, you know, and that's incredible.
That's how mystery works.
Yeah.
Thank you very much for this answer. And as I promised, just the last one, I wanted to ask you something about the Science Foundation, especially about your projects that you are doing here in Ukraine. At the beginning of this year, in January, the Science Foundation announced supporting of more than 400 Ukrainian scientists. So how things are going on right now? How do you estimate the success of these projects at the moment? It's been like 6 months. And what would you probably recommend for Ukrainian scientists, for everybody who's involved, to like perform well, to build trustful relationships with, American philanthropic community at all? What would be your piece of advice and your estimation?
Well, I think that there are a couple pieces to that question. I think about the stages of supporting Ukrainian science and rebuilding Ukrainian science having 2 parts. There's the sustaining stage. What do we do while the war is on? And then there's the stage after victory. And what role should science play? I think one of the things that the Ukrainian scientific community needs to do internally is articulate the importance that science will play in the future of Ukraine. When I was asked about this, the model I think of for Ukraine in some ways is Israel. Israel has existed throughout its existence with more populous surrounding neighbors. It has maintained its security through excellence in its science, which has kept it at its technological edge. And that strength in science has also helped enable it to become a technology superpower in some ways. And that has made it much wealthier. I think the per capita income has tripled since the 1990s. And you know, it has gone from being a country that once was known for exporting oranges to a country that is at the cutting edge of cybersecurity. So I think, and it has done this having to do a lot of defense spending and having survived some wars that could have destroyed it. So you know, not everything is identical, but I think there's some interesting lessons learned in the centrality of science, and investing in the scientific community in doing that is a good model. I think in terms of the way Ukrainian science should develop and what will be important for philanthropic support, but even more important for the health of the science, is that support and proposals whether they're being done internally or externally, need to be reviewed by the international community. That we don't want to be giving money, whether this is done by philanthropy or by the government, just based on who you know and what your roles are. I'll tell you what, some of the things I've done recently. So I helped review Dutch astronomy. So the Dutch did not want to have their universities reviewed by other universities because everyone knows everyone else in the country. So they brought together a committee where I chaired it. We had, Brian Schmidt, who was a Nobel laureate from Australia. We had scientists from Germany and France and Britain, people from the outside evaluate. What we do in the US, we have many competitive calls where our top scientists at all of our major universities compete. And the US is a pretty big country, but nevertheless, within a field, we all sort of know each other. And what we rely on is our European colleagues in the world scientific community to help us review. And if the US is drawing on international reviewers, and the Europeans are, Ukraine, as it thinks about how it wants to evaluate and support science, needs to think about moving to a system of reviewed proposals, grants given to the most outstanding scientists, and making sure that the resources go to the people doing the most innovative work. So I think there needs to be kind of a structural change. And this is something that's exciting opportunities as one moves from what in some ways is a post-colonial structure with some things, kind of a remnant of the Soviet oppression, right, that left some structures in place, that one moves to something that's really competitive external reviews.